the epitome of Asian architecture, a 508-meter tall, 101-story elegant symphony of steel, glass, and concrete, the symbol of the rising Asian economy and the pinnacle of civil engineering. Taipei 101, Taipei 101.
Taipei, capital of Taiwan, houses Taipei 101, a remarkable technological skyscraper. Formerly known as the Taipei Financial Center, it symbolizes the growth and the economic prosperity of Taiwan as a global business invention. T for technology. Ingenious design solutions and engineering achievements set this massive structure apart from a crowded generation of skyscrapers. In this new arms race, Taipei 101 combines disaster prevention features and state-of-the-art aesthetics to conquer this battleground in the sky. A for art. Through much symbolism and deliberate references to Chinese elements and culture, Taipei 101 is a dense system of functional culture. I for innovation. Impressive technological architecture is paired with refreshing features, makes this an internationally recognized symbol. P for people. Built by the people for the people. It is a main hub for contemporary Taiwanese community. E for environment. Taipei 101 is always alive with urban activity, yet it doesn't lose its original meaning, making it an integral part of the urban landscape. I for identity. Creates an East meets West dialogue. The structure features the best Western technology available with reference to the local culture and identity. 101 refers to the number of floors in the building above ground, as well as the idea of renewal, going one step beyond the traditionally complete number of 100. Yes, this is a modern creation. It is all-encompassing. Its characters purposefully generated to represent home, Taiwan, in all its glory and potential. Now that I've introduced to you the core concepts of Taipei 101, let me begin to elaborate on the development history of this iconic structure. Like most miracles, this one started as the brainchild of a true team leader / dream builder, Harris Lin. As the president of Taipei 101, he had a passion instilled in him since young to build something that would last, something that could pass on. In 1997, the mayor of Taipei invited developers to bid for the Xinyi Planned District for conversion into a multifunctional urban area. Lin had to expand his financial team to obey Taiwanese regulations that prohibited insurance companies from investing more than 5% of their assets on a single project. In the same year, Taipei 101 became the first joint effort between the Taipei city government and the private sector, forming the Taipei Financial Corporation, the managing team for Taipei 101. Out of 7 developers, Lin's team emerged as the winner with the highest amount proposed at 2 billion. The initial design proposal did not call for the tallest building in the world. Proposals such as this were considered, but then the decision was made to stack each of the lower buildings on the taller one. Only then did Lin discover that this solution could potentially result in the erection of the world's tallest structure. Featuring the best of both Western and Eastern Grade A office buildings, Taipei 101 had raised the overall quality of real estate in Taiwan as a true mixed-use ensemble, consisting of the best business precinct and imaginative retail environment. Lin believed that a building consists of 2 messages, technology and culture. Working with the architectural firm CYD and partners to fulfill both market requirements and their respective wishes to apply their Chinese cultural roots within the contemporary skyscraper. When a monument like Taipei 101 proves that a highly efficient urban complex can stride undeniably into the future, while unmistakably bringing along its ancient heritage along with it, it is an uplifting reminder that we need not limit the depth of cultural individuality just yet, perhaps never. It may not be the tallest, but just one look at Taipei 101 proves that it is not the only contest worth winning.
The design concept is based on number 8, a numeral representing prosperity in Chinese culture. The design is based on 8 floor interlocking structural units, a rhythmic aesthetic new to skyscraper design. Inclining 7 degrees inwards, the floor module is isolated by smoke and fire barriers and contains independent security systems. At the top are 11 mechanical communications levels, which start back 3 times a 60-meter tall pinnacle rising from 101 story completes the towers at 508 meters. A shopping mall is in the linked 5-story podium. At the base of the tower, wind effects usually created on the surface of high-rise buildings are minimized by the building's zigzag W-shaped corners, a feature designed after wind tunnel testing.
Features. Okay. Among the main features of Taipei 101 is being among the tallest buildings in the world. Its height. So exactly how many floors and how tall is the Taipei 101 tower? I'm very glad you asked. It's called the Taipei 101, so of course it spans 101 floors, right? Wrong! Just the Taipei 101 tower has 101 floors above ground and also 5 underground. Upon completion, it claimed records for ground the highest architectural structure, that is at 508 meters high, which was previously held by Petronas Twin Towers. Ground to roof at 449 meters, and also ground the highest occupied floor at 438 meters. It also has the fastest ascending elevator speed, designed to go at about 60.6 kilometers an hour. This is one elevator that you cannot race against. It also is the tallest sundial in the world, because people still use those things. Taipei 101 was the first building in the world to break the half-kilometer mark in height. The record it claimed for greatest height from ground to pinnacle was surpassed by the Burj Al Khalifa in Dubai. The height of 101 floors commemorates the renewal of time, that is, the new century that arrived as the tower was built, and all the new years that follow. It symbolizes high ideals by going one better on 100, a traditional number of perfection. The repeated segments simultaneously recall the rhythms of an Asian pagoda. The tower linking earth and sky, also evoked in the Petronas Towers. A stalk of bamboo, an icon of learning and growth, and a stack of ancient Chinese ingots or money boxes, a symbol of abundance. Popular humor sometimes likens the building's shape to a stack of takeout boxes used in Western-style Chinese food. Of course, the stackable shape of such boxes is likewise derived from that of ancient money boxes. 4 discs mounted on each face of the building where the pedestal meets the tower represent coins. The emblem placed over entrances shows 3 gold coins of ancient design, with central holes shaped to imply the Arabic numerals 101. Aside from height, another contribution to the iconic appearance of Taipei 101 is its beautiful blue-green facade. Taipei 101's characteristic blue-green glass curtain walls are double pan and glazed, offer heat and UV protection sufficient to block external heat by 50%, and can sustain impacts of 7 tons. That's a lot of tons. The facade system of glass and aluminium panels installed into an inclined moment-resisting lattices contributes to original lateral rigidity by tying back to the mega columns and 1-story high trusses at every 8th floor. This facade system is therefore able to withstand up to 95 millimeters of seismic lateral displacements without damage. Taipei 101's own roof and facade recycled water system meets 20 to 30% of the building's water needs. These features culminated in Taipei 101 obtaining the honor of the world's tallest green building by the standards in July 2011.
Taipei 101 took 4 years to build and proved itself to be a massive engineering challenge. Through those 4 years, an army of workers labored tirelessly on site. At the same time, the world's brightest engineers, geologists, scientists, and surveyors calculated and designed a myriad of innovative solutions to solve the problems building gave. Construction of the building started on the 13th of January 1999 with the groundbreaking ceremony. Nearly every day for those 4 years, up to 2,000 workers worked every day on this building. They first laid the foundation of the building, a massive 23,000 meter cube concrete slab with 382 concrete piles that dig over 60 meters into the bedrock. Those piles transfer the immense weight of the building onto the rock. Then, they encountered problems. Taipei 101 was built on a seismically active area. In fact, it was only 200 meters away from a major fault line, and Taiwan itself was located close to the meeting point between two gigantic tectonic plates. In addition, the tower had to withstand destructive typhoons with building-destroying levels of wind. The surface area of the building alone was so large that even a tiny breeze could create a dangerous force on the building. Larger winds would create vortices that oscillate, pushing the building from every side and causing it to violently sway. Normally, the solution to combating wind is to make it as stiff as possible, while the solution to combating tremors was to make the building as flexible as possible. In Taipei 101's case, it would have to be both stiff and flexible. This was no easy task. Eventually, the engineers found a couple of solutions. By combining the flexible qualities of steel and the stiffness of concrete into 8 massive mega columns, the building could exhibit both stiffness and flexibility. The inward slanting design of the towers helped redirect the energy from the earthquake onto the center of the building where it is most stable. In addition, the jagged edge design of the facade reduces vortices by up to 30%. But perhaps the most famous of them all is a massive 660-ton tuned mass damper, a gigantic golden ball located 380 meters on the building. This counteracts the force of winds and basically symbolizes the building. However, though these solutions work very well on paper, nobody knew if it would translate to real-world success. On the 31st of March 2002 at 2:52 in the afternoon, Taipei was struck by a massive 6.8 magnitude earthquake. Over 100 houses were destroyed and 5 large buildings collapsed in Taipei. At the construction site, 2 cranes toppled over and fell from the 47th floor onto the ground below. On that dark day, 5 workers and a taxi driver were killed. But in the midst of all this chaos, the partially constructed tower stood tall, unaffected. Construction resumed after a 3-month hiatus as surveyors cautiously inspected the building for any signs of damage. The conclusion was Taipei 101 survived unscathed from the disaster, demonstrating the merits of its design. The tuned mass damper is located suspended from the 92nd floor to the 87th floor. While mass dampers have been used in buildings before, no one was this big, this massive, and this high. The TMD came in prefabricated parts and welded on site. Suspending this 660-ton golden ball are 16 10 cm thick metal cables. Today, the TMD is actually open to the public and one could see it moving in action. By 2004, all major works on the tower are complete, leaving only the massive pinnacle to be placed. A 60-meter tall, 400-ton structure was slowly hoisted up 450 meters by gigantic hydraulic pipes and metal cables. It was a very slow and arduous process. It took 14 days to lift it up and secure it, but on the 17th of October, the last bolt was placed, screwed into position, and the Taipei 101 is complete.
Skyscrapers must be flexible in strong winds yet remain rigid enough to prevent large sideways movement. Gale winds up to 134 miles per hour and the strongest earthquakes likely to occur in the 2,500 year cycle in Taiwan. The 16,000 facade elements of the tower are 4.1 meters high and 1.5 meters wide, consists of primary glazing, rust-proof steel and aluminium. The 4,000 facade elements of the podium were made of glass, sheet metal, and natural stone. The podium roof itself is made of cursed steel and glass. Flexibility prevents structural damage, while resistance ensures comfort for the occupants, and protection of glass, curtain walls, and other features. Most designs achieve the necessary strength by enlarging critical structures, elements such as bracing. The height of Taipei 101 combine the demands of its environment to call for additional innovations. The design achieves both strength and flexibility for the tower with the use of high-performance steel construction. 36 columns for Taipei 101, including 8 mega columns packed with 10,000 psi of concrete. The steel megastructure provides maximum strength and stability. High-strength steel blocks, columns filled with strengthened reinforced concrete, form a strong framework, as well as a massive steel outrigger. Trusses connect the mega columns to the core. As the height of the tower increases dramatically, new problems appear. Concrete, the main support material for the building, is extremely heavy and must be quickly laid and transported on the site before it could set. To combat this, engineers devised special concrete with different viscosities and drying times, buying precious time for the concrete to reach the site. Powerful pumps bring the concrete up vertically to a dizzying height of 450 meters. This set a new world record. These features combined with the solidity of its foundation to make Taipei 101 one of the most stable buildings ever constructed. Foundation is reinforced by 380 piles driven 80 meters into the ground, extending as far as 30 meters into the bedrock. Each pile is 1.5 meters thick in diameter and can bear a load of 1,000 to 1,320 tons. Important to Massetti engineers, along with Evergreen Consulting, designed a 660-ton steel pendulum that serves as a tube mass damper at a total material cost of 132 million. Suspended from the 92nd floor to the 87th floor, the pendulum sways to offset movements in the building caused by strong gusts or earthquakes. Its sphere, the largest ever sphere in the world, consists of 41 circular steel plates which were picked for its environmental role because it can be recycled. Plates, each 12.5 meters thick, are welded together to form a 5.5 80 feet diameter sphere. Two additional tube mass dampers, each weighing 6 tons, are installed at the tip of the sphere, which help prevent damage to the structure due to strong wind loads. It is suspended by 8 steel cables, each 42 meters in length and 9 cm wide. Each cable is composed of more than 2,000 smaller cables which affect stability and durability. Furthermore, the double low E-glass facade was selected as it reduces heat by 2 turns. Grey water is also used to flush the toilets as well as to cool down the building. There are also several special plating features such as the 2-story high 32 stainless steel elements weighing 5 tons each at the 14-meter diameter disc with a projection of 4 meters. The 7-story podium consists of many different systems, skylights, as well as 5mm thick medium posts systems. Stainless steel and granite sharp fronts, complex canopy designs, and pointing system glazing. The podium is enclosed by a 42-meter high glass skylight, one of the world's largest indoor public spaces, as well as glass enclosed elevators designed specifically for the ambience of the structure.
The epitome of Asian architecture, a 508-meter tall, 101-story elegant symphony of steel, glass, and concrete, the symbol of the
Each 8 stories sit above the lower 35-story section with an inward slope of 5 degrees.
It also is the tallest sundial in the world. Because people still use it.
There are also several special plating features such as the 2-story high 32 stainless steel element.
Available from every side and causing it to violently sway. Normally, the solution to combating wind is to make it as stiff as possible.
Taipei 101, Taipei 101.